Mr. Ryan, how are you today?
Good.
It's Friday, yeah? Have a good weekend, yeah? Okay.
Is it 2 days later it will be the bank holiday?
Yeah, bank holiday. Okay, so today we talk about sum of 4. Remember we have talked about 3 sums, right?
Yeah.
Now we talk about 4 sums. Sum of 4. But today,
The sum of 4 is 1 plus 3, 2 plus 2, and 3 plus 1, and 4 plus 0, and 0 plus 4. It's easy.
Something like that. Okay, so listen. Sum of 4 is basically like picking 4 numbers.
And you have a target.
Target, well done. And we have different ways of doing that, but today we are going to talk about using algorithm. You already know before.
No, but
No.
brute forcing.
Brute forcing, yeah, kind of brute forcing. Depth first search. Yeah, depth first search. Okay.
How come?
Yeah. Good question. How come? So let's pick 4 numbers. So let's say 2, 3, 4, 6, 7, 9. Let's see if pick any numbers can add it to let's say 21. Okay, we want to find the 21. If there are any 4 numbers adding to 41. Yeah? You just need to tell me if it's true or false. That's true. If you can find 4 numbers, 4 distinct, unique number, distinct, yeah? You know this now? Distinct. Unique numbers. 4 unique numbers. You cannot pick one number twice. Yeah? You want to pick 4 numbers. We want to pick 4 numbers. Let's sum up to target 21. So I give you a hint. We can use the depth first search. Of course, we can have a 2-pointer thing, but let's make it tomorrow or in the future. But today we're going to focus using depth first search to solve this problem.
It's this one,
Yeah.
and this one.
5, yeah, or 10, 1, 4, 6. I was thinking of 10, 1, but again, it's the same. It's different answers, yes. But we can choose. Right? We only need to tell if it's possible to use the 4 numbers that sum up to 21.
10, 9, 2.
No, that's only 3 numbers. Yeah, we want the 4 numbers. Yeah, so 10, 1, 4, 6, yeah, or 3, 7. Yeah. Okay. So how can we use the depth first search? I give you a hint that for this number, we can go through this. We can search from the beginning to the right. Yeah, from the beginning to the right. For each number, how many choices do we have? How many choices do we have?
The number of.
If I have a depth first search function, right? If I have which number have we picked so far? We have a left.
10.
And then we have a count. How many numbers we have picked so far? And then the remaining sum. Okay, the remaining sum. Does it make sense? So at the beginning we can put this as the target, right? We want to pick this number, right? The target. Yeah. Alright. And then this count at the beginning will be 0. Alright. And then we need to check if the count equals 4, right? We only need the 4 numbers. And left will be beginning. So for each one, let's go through the left to the right. For each one, for each left, suppose left is here. For this 10, how many choices do we have for the number 10? No, I'm just talking about the 10. How many choices do we for this 10 in the final answer? Like, do we have a...
We can pick it and not pick it.
Well done, that's what I'm looking for. So for each number, we have 2 choices. Pick it or not pick it. For pick it, if I pick it, what happened to this count?
You add
Count will be...
value.
No, the count will be how many numbers we have picked so far. So what happened to the count if I pick it?
It adds 10.
Count, the number, not the sum. Count. How many numbers do we need to pick? How many numbers have we picked so far? If we pick this number, so count what?
1. Add 1.
Add 1, okay. So target would be what? How many numbers do we need to... The sum will be minus 10, yeah? Minus the number, right? Yes? Yeah? Okay, let's say minus 10. And then left, and then we can go through the next one, will be left plus 1, right? Yeah? Yeah? This is if we pick. And how about if we don't pick? If we don't pick this one, right? And this is still left plus 1, right? Because we consider the next number, right? Count will be what? What happened? What happened to this count? If we don't pick this, what happened to this count? Look at this. If we don't pick this number.
Subtract.
No, if we don't pick this number, what happened to the count?
Just stay the same.
Yeah, count. And then this target will be what?
The same.
The same. So you see? So there are only two choices with depth first search. If we pick count plus 1, depth plus 1, count plus 1, target minus this number. If we don't pick, we just skip to left plus 1, right? And then when left reach the end, we return false because we run out the numbers. If count equals 4, so look, if count equals 4, what should we do now? If we have already picked 4 numbers, but the target is not 0, so what does it mean?
What?
If we have picked 4 numbers, but the target, the remaining sum is not 0, what does it mean?
What, not 0?
Remaining sum, remember the target, if we pick 10, we need to minus 10, right?
Yeah.
If we have already picked 4 numbers and then the current sum, the current remaining is not 0, what does it mean? It means that.
What's the target?
Remember, we want to pick 21. At the beginning, it's 21, right? We want to pick 21. And then if we pick 10, with 21 minus 10, and we have a remaining 11 to pick, right? If this count equals 4, if we already picked 4 numbers, but the remaining is not 0, what does it mean?
It means, well, it means you have to try again.
Yeah, of course. That means that false, yeah? Because we count, yeah? That's what I mean. If it's 0, it means that what? It's true, yeah? We found the 4 numbers, right? Yeah. So does it make sense, this one?
Yeah.
Okay, let's write it. Ryan, do you understand?
Yeah. Four sum.
That's what search. Look at the 4 sum, yeah? 4
Always define.
sum.
You can jump into the
Okay.
every time.
Then we have a numbers here and a target, right? Target, okay, column, yeah? And then we define the depth first search here, right? Define depth first search. And we have a left, yeah, left. And count, okay, count. And then a target, yeah, another target, yeah? Okay? Look, Eric. If count, Eric, look, if count equals 4, we have already picked 4 numbers. So what should we return?
If it's not 0.
So return t equals 0, right? Does it make sense? If left bigger or equal than nums, what should we do now? Return what? If we have run out of numbers, what should we do? If length,
return false.
Yeah, return false. Okay. Okay. And now we have 2 choices, yeah? We have 2 choices, yeah? Let's say pick equals what? DFS left plus 1, right? And then what? We pick what? Can you tell me what should I put here? Left plus 1, and then if we pick what?
Right.
No, count what?
Count
what?
minus
What?
add
Add what? If we pick a count, how many numbers we pick?
1.
1. And then target minus what? Nums left. Okay. Okay, not pick. Equals depth first search. We skip this number and count what? Just count, yeah? And then
T.
T.
Just T.
Okay. And then what? Return what?
True.
Return what? We have pick and not pick, so the result is what?
Pick. Not pick.
Return. So if one of them is true, then it's true, right?
Yeah.
Yeah. Return pick or
Not pick.
not pick. Remember, this is not pick is a variable, yeah? It's not actually not, right?
What does sound complete?
Okay, and then here I should just call this function, right? Return DFS. What should I give this number? The L, the initial value will be what? L is what? The first one is what? The first element. 0. Okay, and then
0.
count is what?
0.
At the beginning we haven't picked anything. And then this one, how many times? What should I put the third parameter?
Target.
Target, which is T. Okay. That's it. Does it make sense?
Yeah.
DFS. Yeah. Then we define an inline DFS function here. What's the time complexity?
N.
We are picking 4 numbers. So how many kind of solutions?
4. O4. O1.
O and what?
O-N.
O to the power of 4. Yeah, you're quite correct.
Well.
Yeah.
That's quite
Because look, we are picking for
Then ON for the next one.
Space complexity. For why is it ON for? Why is it ON for? Because they are given n numbers, we can iterate these n numbers in the for loop, right? Yeah, choosing 4 numbers, right? Does it make sense, Eric? So we can choose for I in nums, right? For j, for first number in nums, and then for second number in nums, for third numbers in nums, and then for fourth numbers in num, okay? And then we can brute force it. Does it make sense? Yeah? We can actually do using this kind of solution. Yeah? For first number in nums, for second number in nums, why the second number is not equal to first number, yeah? So actually we can use the range. For I in 0 to nums, for j in I plus 1 to nums, to n. For k equals j plus 1 to n. For u equals k plus 1 to n. And then if nums I plus nums, j plus nums, k plus nums, u equals t, return true, right? It also works. Does it make sense?
Yeah.
And then in that case, how many fours? So what's the time complexity?
What?
What's the time complexity of this one?
O
4 loops.
N.
This is n, this is n, this is n.
O N to the power 4. Yeah.
n to the power 4. Yeah, that's the same. But this one is using the depth first search.
What
Yeah?
is space
Because
complexity?
for this one, it's O1 because we are not using any space. This one is OM because we're using the recursion. Yeah, recursion. You have the left will be from 0 to the n, right? Okay, does it make sense, Eric?
Yeah.
Okay. Does it make
So
sense? Yeah.
about then N.
Yeah.
Right?
Log it out here. Okay,
Then
so
N.
that's it.
Then N.
So what should we do at the beginning? We want to check if what? If what? If we
Mario
already picked 4 numbers, what should we do?
If counter equals
Yeah. If we already picked 4 numbers, we should check what? We should check which variable is 0. Return, yeah? Return what?
ooh, mommy's doing the hula hoop.
Return what?
Ooh.
No, don't be stupid. Return what? If we pick 4 numbers, we return
Ooh.
the
target.
remaining target equals what?
Target equals 0.
Yeah. This is the same as if t equals 0, return true, else return false. Yeah, we can just put it in the same, right? Okay, you can do some beatboxing.
Beatboxing.
Okay, that's it.